In mathematics, the term ergodic is used to describe a dynamical system which, broadly speaking, has the same behavior averaged over time as averaged over the space of all the system's states. In physics, the term is used to imply that a system satisfies the ergodic hypothesis of thermodynamics. In statistics, the term describes a random process for which the time average of one sequence of events is the same as the ensemble average. In other words, for a Markov chain, as one increases the steps, there exists a positive probability measure at step that is independent of the probability distribution at initial step 0. Etymology. The term ergodic was derived from the Greek words epsilon rho gamma omicron nu and omicron delta omicron sigma. It was chosen by Boltzmann while he was working on a problem in statistical mechanics. Formal definition. Let be a probability space, and be a measure-preserving transformation. We say that T is ergodic with respect to if one of the following equivalent statements is true. For every with either or, for every with we have or, for every with positive measure we have, for every two sets E and H of positive measure, there exists an n greater than 0 such that every measurable function with is almost surely constant. Let Tt be a measurable flow on an element A of sigma is invariant mod 0 under Tt if for each T are measurable sets invariant mod 0 under a flow or a semigroup action form the invariant subalgebra of sigma, and the corresponding measure-preserving dynamical system is ergodic if the invariant subalgebra is the trivial sigma algebra consisting of the sets of measure 0 and the complements in X. Markov chains. In a Markov chain, a state is said to be ergodic if it is aperiodic and positive recurrent. If all states in a Markov chain are ergodic, then the chain is said to be ergodic. A Markov chain is ergodic if there is a strictly positive probability to pass from any state to any other state in one step. Examples in electronics. Ergodicity is where the ensemble average equals the time average. Each resistor has thermal noise associated with it and it depends on the temperature. Take n resistors and plot the voltage across those resistors for a long period. For each resistor you will have a waveform. Calculate the average value of that waveform. This gives you the time average. You should also note that you have n waveforms as we have n resistors. These n plots are known as an ensemble. Now take a particular instant of time in all those plots and find the average value of the voltage. That gives you the ensemble average for each plot. If both ensemble average and time average are the same, then it is ergodic. Ergodic decomposition. Conceptually, ergodicity of a dynamical system is a certain irreducibility property, akin to the notions of irreducibility in the theory of Markov chains, irreducible representation in algebra and prime number in arithmetic. A general measure-preserving transformation or flow on a Lebesgue space admits a canonical decomposition into its ergodic components, each of which is ergodic.